Welcome to qnawire.
For the given problem, we can write B to be mu times I times a square divided by 2 times of x square plus a square 3 over 2. Since we are only concerned with the magnetic field directly in the center of the loop and not at any distance from it, we set x to be 0 and a is the radius of inner center, which is 0.10 meter. Then our b will be 4 pi times 10 to the power minus 7 times 12 ampere times 0.10 square divided by 2 times of 0.10 square times this whole times 3 over 2. This gives us b to be 7.5 times 10 to the power minus 5 Tesla. We set this answer to the expression we just used and change a to reflect the larger radius. In order for these fields to cancel each other, the current in the larger loop must be traveling in opposite direction, which is counterclockwise. Then we set 7.5 4 times 10 to the power minus 5 is equal to 4 pi times 10 to the power minus 7 I times 0.15 square divided by 2 times 0.15 square, this whole 3 over 2. From here we find I to be 18 amperes. So this is our answer.